Alright, this is a short video for Math 2, and what we're going to look at is the rest of the 11-1 examples. So we put this examples page on page 48 of your notebook, and we did all the way up through 3a. So I just want to finish it and also want to show you how to add or subtract polynomials. Alright, so starting with 3b, we have 8x plus x plus 5 plus x cubed, and we need to put it into standard form and then classify it by or give the name of the polynomial based on its degree and number of terms. So in the last one we put it in the standard form by putting it in descending order of degree of each term. So the degree of this term is 1 and this term is 1. And so actually you shouldn't, in standard form, you shouldn't have two of the same degree because that means you can combine them. So we should start by doing that. 8x plus x is 9x. And notice the exponent does not change. Plus 5 plus x cubed. Okay, so now we still need to put it in descending order. The highest degree term is the x cubed term, followed by the 9x term, which is a degree of 1, followed by the constant term. The constant term, the one without the variables, should always be the one at the end. Okay? Alright, so now to classify it, this is the degree of the polynomial is the highest power, which is 3. And so we could say that that is a cubic. And it is not 4 terms now, it's 3 terms, so this is a cubic trinomial. Alright, let's talk about adding and subtracting polynomials. Now, we talked about adding monomials, so one term at a time, that have the same combination of variables and exponents. So we can add these together, and if you have a bunch of different terms together, you want to find those like terms and add them together. So let's look at 4. We are doing addition here. And this problem is presented to us horizontally, and you're also going to see it presented vertically. So what I mean by presented vertically is you could have this as a problem such as this. 4, negative 4s cubed. Actually, let me use a thinner pen. Okay, negative 4s cubed plus 2s minus 3. And do you notice how there's no squared term? And so if we were doing it vertically, you'd actually leave a space there for the squared term, or you can even say it's 0s squared. Right? There are no s squareds in this. I'm looking at just this one right here. And then following that is 2s and then minus 3. So then what you would do with the second one that we're adding, it would look like this. You would line up the like terms. So for example, in the second one I don't have any cubes, so I'm not going to put anything here. I do have an s squared term, right? I have a negative 2s squared term. So I'm going to line that up with the other s squared term. Okay, so I'm looking for common or like terms here. I have an s term, which is a degree of 1. So that goes next. So we can see the s, those are like terms. And then we do have a constant of plus 7. Constants are always going to be like terms to each other. Alright, and then we don't have any cubed terms other than this one. Okay, so then when we add it together, we add vertically. So that'd be negative 4s cubed, because there were no other s cubes, minus 2s squared, plus 3s, plus 4. And doing it this way, you get the answer in standard form. Everything should always be put in standard form from highest power to lowest power. So this is how you would do it vertically. You can also do it just the way it is, but you're still going to recognize the like terms. So starting with s cubes, I don't see any other s cubes, so I would just write, okay, negative 4s cubed, and I'm starting with the highest power. That was the highest power. And then I look for the next lowest power, which are the squareds. And I see this one. That's the only one there is, so I'm going to go ahead and just write it down. Then I go on to the linear terms, the 1 degree terms, and we see that we do have to add there. We have negative 2s plus s, which would give you plus 3s. And then last but not least, we have the constants. So negative 3 plus 7, which would be 4. So you get the same answer either way. I just want to show you both horizontal and vertical because you're going to see both in your homework. All right, let's talk about subtraction. Subtraction is pretty much not the same kind of problem. There's just one major step in the beginning. What I like to do for the subtraction problems is I'm going to distribute that negative to everything in this set parentheses right here. Okay, so this polynomial. I don't need to distribute a plus, it doesn't do anything, but this is like a negative 1 right here. So I have to multiply everything by a negative 1. So that's always the first thing I'm going to do. The first parentheses are not going to change at all. So I'm just going to copy everything that I see. And then I'm going to go ahead and write what I get when I distribute the negative. So negative 1 times a negative 8 cubed would be a positive 8x cubed. A negative 1 times a positive x squared would be a negative x squared. And a negative times a positive 3 would be a negative 3. Then it's just combine your like terms. So look for the same variable, the same exponents. So everything's in x's, so I have x cubed here and here. So I'm really just doing negative 7 plus 1, which would give us 1 x cubed, although as you know the 1 you don't have to write it. Next we have the x squareds. So x squared here, we have 5x squareds and a negative x squared. So 5 and minus 1 is 4x squared, right? Because you could think of this as a minus 1x squared. And then the x's, negative x, there is no other x's, so I'm going to just put it right there. There's nothing to add or subtract to that. And then last but not least, we have the constants, and we have a positive 6 and a negative 3. So 6 minus 3 gives you positive 3. And there's your answer. Now you may see this also in a vertical format, which I don't prefer at all. I think it makes it more confusing. But if you see it, it'll look like this. And remember, you're going to line up the terms here. So we've got our x cubes, x squareds, there's only one x, and then the constants, they should be lined up. If they're not, then you should line them up to make it easier. So there's negative is still here. I, would still distribute it, and then it would just become addition, and then you'd get the same answer either way. Or if you prefer, you can always go back and forth. You can take this vertical layout like this one, and you can change it into a layout like this if you prefer, and vice